Okay, so we're going to do a binomial distribution. Now, to do this, we want kind of three things to happen. For our outcomes, we want outcomes to be independent. We want there to be two different possibilities, or we can create two out of them. What I mean by that is, for example, if I flip a coin, if we flip a coin, there's automatically two outcomes, head and tail. If I roll a die, we naturally think that there's 6 outcomes. But if I decide to say that we want a 3 or not a 3, then that would make it 2 outcomes. Okay, so either they come naturally or we can create them. And then we want to repeat them over and over. So when we do this, notice that each one of these have 2 outcomes. So there's one thing we're going to call the probability of success, which we're going to write as P of S, and we're going to use a little p to represent the number, and then the probability of failure, we're going to use P of F, and we're going to use a little q for that one. Now the relationship between these two numbers is, since there's only 2 possibilities, that q is equal to 1 minus p. And that's the way they're related. Or another way to say it is you add them together and they have to equal 1. Okay, so probability of success, probability of failure. Now the last one is it has to be repeated. So we're going to repeat the experiment n times. Alright, n times we're going to repeat the experiment. So what we might do is, let's make up an example that we can now follow. So now we have, let's say we're going to roll 3 six-sided dice, okay? So we're going to roll 3 six-sided dice. Alright, so let's see if we can figure out what's going on here. So our random variable, we need to now decide what we're going to do. Our random variable will be the number of 3s that we can that show when we roll them. Okay, so for example, we might have 3, 3, and then some other number like that. Alright, so I stopped it for a second so that I could just pick out some dice, but here's our 3 dice. And here's what I was saying, 3, 3, and then something else. Now you could roll them again. Here we'd have, that's kind of cool, but no 3s, 0 3s, there's 2 3s, there's 0 3s, there's 1 3, and so on. You do it over and over. So you count the number of 3s on a roll. Now, from a problem point of view, it would be the same thing as rolling it 3 times, like that. No 3s and 3 rolls. But we'll do it this way, roll 3 at a time. So the number of 3 shows. Now how many could we possibly have? Well, 0, 1, 2, and 3. Okay, so that's how many 3s we could have at each time we roll 3 dice. Now, how do we figure out what the probabilities are? Well, let's use this example for what we're doing. So suppose we want to find the probability that 2 3s, 2 3s are showing, like that. So what's the chance that that's going to happen? Well, let's put here's our 3 dice, right? We have there has to be one that's not, one that is, and another one that is. Okay? So let's suppose that we do that. Now what's the probability? Well, the probability that the first one is 1 out of 6. Now because it's independent, these aren't going to the probability is that each one's not going to affect each other, so this is 1 over 6. Now this one is 5 out of 6 because there's 5 different sides that give us the result. Now, if we think of it this way, we can arrange them in different fashions like this, right? I could have the 2 3s on one die, I could have them in between, I could have them on the end. So there's different arrangements of them. So the same probability would still occur each time, but they would come in a different order. But if you notice, if we group them together, that they all have the same probability when we write it like this. Because all of them, because addition is commutative, so we can rewrite them like this. Now, the other thing is we don't want to calculate this each time, so what we do is we figure out how many ways can we arrange these. Well, how many different ways can I arrange 2 things among 3? Well, the way you do that is this number, notice that there's 3, is 3 things, and we're choosing 2 of them to be the 3s. Of the 3 dice, 1, 2, 3, 2 of them have to be 3s. How many ways there is that? So notice, how many ways is there? So notice that this one times one of these will give us our probability that x equals 2 is 3 dice. We're going to choose 2 times probability of success twice, probability of failure once, like that. Okay, so that actually is going to give us a formula. So this formula that we're going to use is the probability that it's x is there's going to be n trials, right? N is the number of trials, or the number of repetitions that you do the experiment, or in this case the number of dice that we use. And then whatever x is, how many successes we want to see. Like that. Then times the probability of success raised to the how many times we have. So little p, remember, was the probability of success. And of course q to the n minus x, which is our probability of failure, how many times that we didn't get that success. Alright, and so this is going to give us our formula for a probability distribution. So the distribution, of course, a table, and then we'd set it up for each one of them. So if I were to actually do this with the example that we did, x, probability of x, we'd have 0 choices. So you have 3 dice, 0 3s, 1 6 to the 0, 5 6 to the 3. And then for 1 3, you'd have 3, one of them is a 3 of the 3 dice, 1 6 to the 1, 5 6 to the 2. Alright, and then we have 2, so this is 3 dice, 2 of them are 3s, probability of success, and how many times we get it, probability of failure, how many times that happens, and then lastly, 3 successes, 3 choose 3, 1 6 to the 3rd, 5 6 to the 3rd, 5 6 to the 0. And we get our, this would be, if we calculate each one of these, this would be our probability distribution. So do our calculator at this time and figure out what each one of them are. We have our answer. Alright? That's the probability distribution.